This year, the Volvo Cars Safety Center Crash Lab celebrates its 20th anniversary. At the time of its opening, it was the most advanced crash lab in the world, and in many ways it still is today.
When inaugurating this facility 20 years ago, it was unique in its appearance, enabling us to recreate any type of crashes that our team find in the real world, with real people in real traffic.
Before a physical crash test, the car model has already gone through thousands of computer-simulated scenarios.
At Volvo, we set our own standards. We develop beyond what is rating and what is a legal requirement. We do that based on what we see in the field.
The Crash Lab contains 2 test tracks of 108 and 154 meters long, respectively. The shorter track is adjustable between 0 and 90 degrees, allowing for different crash angles. Cars can be crashed at speeds up to 120 kilometers per hour.
At Volvo Cars, we have a vision that no one should be seriously injured or killed in a new Volvo. Having that mindset in combination with very dedicated people, a dedicated organization, and facilities like this is really what makes the difference.
The outside area is used for performing tests like rollover crashes and run-off-road scenarios, whereby cars are launched into a ditch at high speeds. Both the car and the barriers are fitted with sensors that register the entire chain of events in detail. Dozens of ultra-high-definition cameras also film the impact from multiple angles. Since its opening in 2000, the lab has crashed on average 1 car every day.
Safety has been at the core of everything we do since 1927. For us, it has always been about protecting people.
I'm really excited with all the possibilities with electrification, connectivity, and autonomous drive. And I know this lab will continue to help us save lives also in the future.
Ready? 3, 2, 1, go! Today we have dropped 10 cars from 30 meters from a crane. We do that because the rescue team or emergency service needed to develop new methods to release people inside the car with a severe crash.
We are several different rescue services that cooperate to find best practice in tools and methods and tactics regarding extrication in car accidents. Today we are testing our methods and really going about it in such a scientific way as we can. We try to measure everything, what pressure we use, how much force we have to use, how much time different methods take, all of those things. The goal is for us to be better at our job and to get access to people in crashed cars in less time.
Normally we crash cars in the laboratory, and this was the first time we dropped them from a crane. We see extreme deformation after the test. And we do this to give the rescue team a real challenge to work with.
There are some different scenarios where we do extrications in modern cars. For instance, when a car hits a larger vehicle, or when we have accidents in very high speed, or when we have situations where a car is hit where there are no crumple zones, for instance like the T-bone accident. In these kind of situations, the people in the car are usually in a critical situation. We usually talk about the golden hour, and that means we have to have the patient in the hospital at the latest 1 hour after the accident has happened. A problem we have as fire brigade is that when we do train normally, we usually get our cars from scrap yards, and these cars are most often 10, 15, maybe 20 years old, and they work very differently from the cars today regarding safety and hardness in the steel and how they work when we try to open them up. So therefore it's extremely important for us to work with new cars. Our work here will end up in a report, and that's not just for us who's working here today. It will hopefully be used all over Sweden and possibly internationally too.
The reason that we work close together is because we have the same goal, and that's to have safe roads.
So when we're developing self-driving cars and technologies around collision avoidance, for instance, it is really important that we cover all possible scenarios that could happen on the road. It's really important that we try to see the human behavior in this aspect as well, because some of these scenarios are either too dangerous to test in real life or they're too rare. The tool that we're using today, it's a game engine from Unity, where it's a real-time 3D tool where it's kind of the innovation hub where we tie all these things together, where we create virtual environments, we bring our cars, test sensors. Then we have VR headset where we can actually put the user in the simulation and track their eyes and interactions with our systems. And finally, collaboration with the Tesla suit, which is fully haptic suit, where we can add the feel of touch in a virtual environment.
This is really where we combined all the technology that you've seen here previously.
Okay.
So we have the unit environment and the headset and the Tesla suit, and we can mix that together and do all the things combined while driving on the road. Everything that you see from this point and forward is exactly what the driver sees. It's from the driver's point of view. And now we're going to do a transition from this physical XC90 to a virtual XC60 through this blue transition. And now we can see the XC60 is building up, and we have the correct speed injected from the car into the virtual content, and also the steering wheel movements. So the scenario we will play out now, we're going to bring a virtual object in front of the car, and the car will detect that object and automatically brake in order to prevent driving into the object. So here we can see it moves to the right and the car detects it and auto brakes. So this is some of the scenarios that we can perform with this very advanced test rig.
We like to call them Volvo's own in-house detectives. You could also call them our own CSI team, with a little twist on the famous acronym, because this amazing group of people act as our crash scene investigators. The Volvo Car Accident Research Team works to make sure that we learn from real-life accidents and constantly improve our cars. The team has been in operation since 1970. They're constantly on call, and whenever an accident involving a Volvo occurs around Gothenburg, Sweden, they quickly get to the scene. As they arrive there, the investigations start. They document and figure out the sequence of events as detailed as possible. The work continues back at the office. Police reports are requested, the driver is contacted, and the car is examined. How are the passengers? How forceful was the impact? How quickly did the active safety systems intervene? It's all part of vital data gathering. A lot of effort is also spent understanding how the driver experienced the accident. What was the cause of the accident? This involves the safety center's behavioral scientists. Other questions include: what was the weather like? What was the time? In what conditions were the road markings? Finally, the team will ask people involved in the accident to share their medical records, which also allows the team to take note of any injuries sustained. These are later analyzed by experts in biomechanics in cooperation with physicists to understand the exact cause of the injury. By figuring out and analyzing what has happened during each phase of the accident research team provides relevant information on what could be improved. All the data and knowledge they collect is shared with Volvo's product development teams, who use it to develop and implement new technologies in upcoming cars. This is what allows Volvo to constantly be at the forefront of safety development. The accident research team is far from the only source of research data for Volvo's safety experts, but it plays an important role. Accidents do still happen, but the consequences are much milder now, and serious injuries are much rarer than they used to be. The team's hard work and research allows Volvo to make sure that a tragic traffic accident can lead to something good. Ever safer cars.
To protect the child in the car, there are two main principles. For the youngest, you need to protect the neck and their head. And for those a bit older that can go forward-facing using the adult restraints, they need to be adapted to the seat belt. Children have a vulnerable neck that is not developed until after a couple of years. It's simply not strong, and the head is very heavy in comparison to the rest of the body. So the youngest kids, they need to go rearward-facing. This is an infant seat. This is typically the first seat that you use for the child's protection in cars. Rearward facing, of course, to make sure to protect the child in case of a crash. Typically, this type of seat is used as long as you want to carry the child in the seat with you, up to approximately 1 year of age. When outgrown the infant seat, the child should use a large rearward facing child seat like this one for the best protection. The child should stay in this type of seat up to age 4. When outgrown the large rearward-facing child seat and 4 years old, the child can use a booster, either a booster cushion or a booster seat like this with a seat backrest. The child needs to use boosters until they graduate to the adult seatbelt only, and that's approximately 140 centimeters, 10 years of age. I think the most important message to every parent is how the kids are actually designed. Children have a vulnerable neck that is not developed until after a couple of years. It's simply not strong. So the smallest children, they need to go rearward facing, and we need to communicate this message to everybody so they understand the importance of having their children rearward facing. Because if they end up in a high severity frontal impact, it's a question of life or death. Sweden is unique in the area of child safety. It all started here. So we have more than 50 years experience of child safety in cars. We invented the first rearward-facing child seat. We were the inventors of the booster seats. We have, together in Sweden, working cross-functional authorities, industry, researchers, with the one voice, emphasize the best protection for the child. We've been doing so since the late 60s. So based on that experience, we know that children are best protected rearward facing. We now see actually globally that the other countries are following our example and keeping the kids rearward facing for longer. So we're moving towards a more safe world for kids in cars. The smallest children, they do need a child seat. You usually start with a baby seat. Position it in the car and they can stay in that one about up to almost a year old. Then you transform into a so-called child seat where they have their own harness and the child seat is attached to the vehicle. For best protection, they need to go rearward facing in those seats. But for simplicity for the parents, it's easier to say go rearward facing up to 4 and then go forward facing. That applies for children up to 4, simply because their neck is too weak. If we say 4, we have the margin that actually children look different. They could be different in height, different in distribution of body parts, different sizes of their head. When the children are 4 years of age about, they have enough size and strength to actually be forward facing using the vehicle restraints, the adult 3-point belt, but need an adapter, a booster that raises them into position so the belt is positioned in the strong parts of the child. The children should stay in boosters up to about 140 centimeters, 10 years of age, depending on the design of the car. Volvo Safety Vision stating that no one should be seriously injured or killed in a new Volvo emphasizes the importance that everybody counts. So everybody's needs need to be addressed. We know that children have specific needs. We know that they need to be restrained according to their needs. And the way to address the vision is to make sure that we can get the children into their restraints so that they will be protected.
When the first generation of airbags were developed in the 80s, they were really aggressive, and there were several severe accidents involving children, mainly unrestrained children. And this caused several countries to forbid children sitting in the front seat. The modern airbag is quite different from the first generation of airbags. The deployment pattern and the way the airbag interacts with the occupant has significantly improved. So we asked ourselves, with this improvement of technology, do we really need to turn the airbag off for a forward-facing child? We did intensive testing and came to the conclusion that for the best protection of a forward-facing child, the airbag should be on, just as for the adults. This is valid for modern airbag designs and only for forward-facing children. So it's really important to understand that even with modern airbags, it's important to turn the airbag off if there's a rearward-facing child in the front seat. In the beginning, this may be a bit confusing, but Volvo has clear recommendations what is valid for your car. However, in a few years, it will be much easier since the new recommendation is much easier to remember. The airbag should be off for rearward-facing children and on for everyone else.